Hey, welcome geometry class. I have missed you guys. I know that you probably have not missed me that much because, who loves math but me? But I still want to let you guys know I've missed you. Hope you all are doing well. I've been praying for you. I know that God is in control and He takes care of everything perfectly because He is perfect and holy. So, we're going to kind of dive into this remote learning head first, and we're going to give it a shot. You guys feel free to maybe encourage me and, let me know if I'm doing something that you like, or tell me to get a ring light or something, I don't know, whatever you guys, maybe a couple of suggestions if you have something. I'd love to hear from you guys. I do miss hearing your feedback and all your really fun comments, but I'm sure I'm going to get to hear some of those, and you'll learn more about that throughout the week. We're going to dive into our circles and circumference lesson, and if you follow along, that's going to be really good. Really, I'm going to need your guys' help. If I'm going to be honest, I need your help. This is different. It's a first for me to teach this way, and it's going to be a first for you to learn this way probably. So you can help me by following along. Maybe on your iPad you can do a split screen, and that way you can have your good notes on one side and this video on the other. I want you to take notes. I want you to try to be engaged. When I ask you to pause the video and answer a question, I'd like you to do that. I want you to do that so you can follow along. Maybe if you can do it at the same time, that's awesome, but I want you to be able to do everything that you need to do in order to not just be successful in my class. I know you guys have heard, I don't want you to be successful just in my class, but through all your life. I want to see God's plan fulfilled in your life. So help me out, and we'll work through this together. I mean, there's probably going to be a few things that don't work, and that's okay, but let's just try it, and we'll get going, okay? Let's see. Circles and circumference. So this is kind of a new lesson. We finished off our last section with test 3, talking about transformations, and now we're kind of diving into a different area, the circle, okay? So a circle is what we're going to be talking about, and this is lesson 10-1 in your textbook, page 697 through 700. If you want to follow along that way, or if you have some questions, there's always good reference material and videos along with your textbook. You guys know, if you have some questions, you're more than welcome to ask me, okay? Let's go over really quickly my goal for this lesson. The essential question, I want you to be able to answer this with a yes by the time we're done, hopefully. Can I identify and use parts of circles? And then, can I solve problems involving the circumference of a circle? Also, we're going to learn how to find those parts of circles in order to use them to solve problems. And we're going to learn more about circumference in order to use it to solve problems. Like we normally do, we're going to learn a concept here in geometry and then use that concept to then solve problems. So let's get going, all right? This is a circle. Wow. I know you guys like mind blown right now. Obviously, you guys know what a circle is. It's one of the first things that you'll learn whenever you're learning shapes. So a circle, this is the actual definition if you're looking for a set definition. It's a set of all points in a plane equidistant from a given point called the center. So it's equidistant from this center point, C. All of these, it's like forming a line, but it's actually a set of like an infinite amount of points, all equidistant from this center, C. Pretty cool. A little bit of a deeper definition than maybe you thought, like it's just a perfect spherical flat shape thing. Okay, this is a more exclusive or deep definition of what a circle is. Okay, we're going to talk through a couple of different segments. segments that intersect a circle have special names, so you know some of these, you probably remember. Maybe you don't, and that's why we're going over it, okay? First, we have radius here. Radius. So the radius is any point, any line that has its end point as a point on the outside of the circle and the center of the circle. So a radius would be, for example, DC, CE, maybe CF. Okay, so those are all radii, being the plural of radius. I know, Greek words, so amazing. Learning new things all the time, right? Then we have a diameter. You guys know a diameter is a line that has its endpoints on the outside of a circle. So D and E. It also crosses through the middle. You will notice that. So D to E is the only diameter shown here. Okay. A chord is similar to a diameter. It has its endpoints on the outside of the circle, but it does not cross through the center. Okay, so you can see this right here. It does not cross through anywhere near this C, this center. Therefore, A, B would be a chord. Okay, kind of like a guitar. You can imagine the center of a guitar hole being this circle, and you guys know the chords kind of go across, but since there are 6 chords on most guitars, I know there are different ones, but 6 chords, none of them actually go right across the center of that circle. So kind of just an easy way to remember, kind of like a guitar chord, doesn't cross the middle, right? Tangent, we've all heard tangent. Someone goes off on a tangent. I've heard you guys repeat some of the other teachers say that or go off on tangents sometimes. Hopefully not me too much, but tangents are kind of just that. It's something that is not really associated with the circle, but it's barely related, okay? A tangent only touches the exterior of the circle, but does not go inside the circle at all. So one of those, infinite amount of points that are here on this outside of the circle, a tangent just touches one of those points and continues on its merry way. So that's kind of where we get a tangent. It's somehow just barely related to what we were talking about, but not really. It just keeps going off. Okay, so GH would be a tangent. We'll talk more about these in its own lesson, not too long from now, but that is a tangent. Okay, so kind of moving forward, I want you guys, okay, let's look. I kind of changed up the circle here a little bit and some of the things going on. Pause the video really quickly, and I want you to either screenshot this or write down the names of the line segments for a radius, a diameter, a chord, and a tangent here in this circle. So pause the video and do that now. All right, I hope you did do that and you were able to find radius. So what's a radius here? There's at least 2 that are here in the circle. Maybe you found one of them. One could be FC. You may have found AC or CA or CF, however you wrote it, but one of these, endpoint on the outside, on the edge of the circle, and the center, okay? Diameter, what about a diameter? Did you find one? Okay, again, there's really only one here. It would be AF, endpoints on the outline of the circle here, but it crosses through the middle. Okay, chord. You guys find a chord? All right, DB would be the only chord shown here. Endpoints on the circle. Sorry about this right here. That should have been right on the edge of the circle, but that's okay. And what about a tangent? Do you find a tangent? Okay. There's not really a tangent here. All right. You might could say this ray E. I kind of threw a little bit of a trick at you, okay? This E is a ray. It's a line that has an endpoint at E and continues for infinity that way, continuing from that arrow. It doesn't even touch the circle, but even if we imagine that it did, it could form a tangent, so maybe you chose this ray E. This GH is just kind of, again, just something to throw you off a little bit and make you think, okay? Wasn't involved at all. All right, so let's keep moving forward. Let's look at our next is finding our radius and our diameter, okay? Radius and diameter. Radius, this is the formula, r equals d divided by 2, or d over 2, or more simply, r equals 1/2 times d. So what is d? What does d stand for? What do you think? Okay, d stands for diameter, so they are connected, right? Diameter, or d, the formula for finding diameter is d equals 2 times r. So pretty simple. You might remember this. This is a pretty basic level geometry, something that you probably did back in elementary or grade school. Okay, so let's look at this. So radius is 1/2 of the diameter, and the diameter is 2 times the radius. See that connection there? Pretty easy. But let's look at a few maybe problems here. Okay, I'll give you these formulas here. And then I'll give you a couple of these problems. If DC equals 8, what is the diameter? If DE equals 11, what's the radius? Take a moment right now and solve that. Okay, I hope you did that. And if DC being a radius, equals 8, what is the diameter? Well, we know the radius is 8. Then we can use our diameter formula, d equals 2 times 8, which should be 16. Good. And DE, that would be a diameter. So if DE equals 11, then what's the radius? Well, if we multiply d by 1/2, we should get our radius. So if d is 11, multiply that by 1/2, or divide it by 2, whichever one works better in your mind. Basically getting half of that. What would the radius be? DE is 11. What would the radius be? Okay, we would assume that it would be 5.5, because 5.5 times 2 is going to be 11. All right. So as we go forward, let's look at a couple of these. So, okay, video might have gotten chopped there a little bit. I'm just going to kind of hustle through this last part here. I apologize if it just got kind of chopped. I'm going to try to do better. This is my first time, like I said, so let's go here. Okay. All right, so we're going to use this formula here to solve for these 3 problems. Really quickly, let's start with this first one. If we've got CE is a radius, equals 4. How do we solve for circumference? Well, we take this formula, C equals 2 pi r, and we multiply 4 and 2. 4 is the radius. 4 and 2 would be 8. And then multiply 8 times 3.14 should be a little bit more than 24. Okay, you should have gotten that as your answer. And let's see, find circumference if d equals 16. Well, if our diameter is 16, to find circumference, we just have to multiply d, which is 16, times pi, which is 3.14. So if we do 16 times 3.14, 16 times 3.14 should be a little bit more than 48. So that should have given you your answer there. Circumference should be close to 48. And then this one's a little bit more tricky. We know the circumference, but we want to find DE, which is the diameter. So DE, diameter, divide circumference, 248.19, divided by pi to get your D. We just kind of divide both sides by pi, and we're left with just getting D. Okay? Thank you for your time. I appreciate it. I'm going to do better and better through each video, hopefully. I love you guys. let's get to work. Thanks.